Test rocket starting from rest at point A is launched by accelerating it along a 200-meter incline at 1.9 meters per second square. The incline rises at 35 degrees above the horizontal, and at the instant the rocket leaves it, the engine turns off and the rocket is subject to gravity only. Ignore air resistance. Find the maximum height above the ground that the rocket reaches and the rocket's greatest horizontal range beyond point A. Here is the picture. At point A, a rocket was launched. And then this is the 200-meter length. The incline is incline length is 200 meters. It is the incline is at an angle of 35 degrees. Now let it be a right angle triangle. So A, B, C. AC is, AC is equal to hypotenuse into cos 35. So our cos 35 is equal to AC by 200. That because cos 35 is the adjacent side, no. So cos 35 is equal to AC by 200, and then sin 35 is equal to BC by 200. So AC is equal to 163.83 and BC is equal to 114.21. These values are required for us. That is why I am finding it here. Now acceleration is given to us as 1.9 meters per second square, and velocity we have to find out. Initially, the rocket is launched with a 0 velocity, and we are finding the final velocity. Okay, starting from rest. A test rocket starting from rest. He gave starting from rest means 0. Initial velocity is 0. And then here we will use the equation Vf square is equal to Va square plus 2A delta y. Here this is the delta y is equal to 200 meters. And then acceleration is 1.9 meters per second square. And plugging in the values, we will get Vf is equal to 27.57 meters per second. Now we have to find out, the question is, what is the maximum height above the ground the rocket reaches? Maximum height we have to find out. And then the rocket's horizontal range. So range we have to find out, maximum height we have to find out. So we will write down the coordinates of the test rocket here. X of t is equal to AC plus Vf cos 35 into t, because AC is the distance, this distance, horizontal range. After this, it will fall. After B, it will fall. Actually, it is like this. It starts from here, goes some height, and then falls like this. This is the line. Okay. This is the line. Am I right? So like this it will be. Now we have to find out delta x and delta y. So from here, this is the total height, maximum height. From here to here, we have to find out maximum height. And then this is the delta y. This distance is the delta y. And then this is the total horizontal range. This is R, range. Okay, so AC plus delta x, this is delta x. This part is delta x. Okay, so x of t is equal to AC plus delta x. Delta x is equal to, we know, distance is equal to Vt. D is equal to Vt. So here V is the x component velocity and time. And then delta total height, maximum height h is equal to BC plus, here this is the BC plus delta y. Delta y is equal to, we know, delta y is equal to VIT plus half AT square. Using this formula, we will find out. So here VT is Vf cos Vf sin 35 times t minus, here A is the acceleration due to gravity g, and t square by 2. Now let us do this one first, because he is asking the maximum height first. So we do this one. To find time, we will use the formula Vf is equal to Vi plus At. And at the maximum height, velocity is equal to 0. And initial velocity will be 27.568 into sin 35 minus 80. So A is 9.8. T we are trying to find out. Solving this one, t is equal to 1.61 seconds. Now plug in this value in this equation. Y is equal to BC is 114.21 plus 27.56 sine 35 into 1.61 minus 9.8 into 1.61 square by 2. So that gives the value y is equal to 128 meters. Now we have to find out the maximum horizontal range. Okay, horizontal distance x beyond point A. So when the rocket will reach the maximum range, when the rocket will fall, when y of t becomes 0, then the rocket will fall. That is the condition. So the maximum height should be 0. Am I right? So for that, what we do is to find the time, we will equate this to 0. So delta y is equal to V80 plus half AT square. No, so 114.21 plus 27.56 sine 35 into t plus half into minus 9.8 t square is equal to 0. Using this one, we will find out t. Same equation, this equation only. Here we plugged in the time. Here we are trying to find out the time. So the time is equal to, we will get two values. One is positive, another one is negative. Because this is a quadratic equation, we have to take the positive value. And then that we have to substitute in this equation. So what is this equation? X is equal to AC plus VF cos 35 into T. So X is equal to 163.83 plus 27.56 cos 35 into 6.75. That gives a value of 315 meters. This is the answer. Okay, one is horizontal range is 315 meters. This is the horizontal range, and maximum height is 128 meters. This is the answer. Okay, hope this helps. Thank you. Bye bye.